In this video, we're going to explore the concept of the geologic sequence. So the geologic sequence is GeologicsSequence, that's the class name. And it's used for assembling complex geological relationships from the modelers that we built previously. These models will be, the output solids coming from the geological sequence will be clipped to topography. If a topo is provided, it honors the chronological ordering of geology, facilitates nesting of units within others, facilitates and honors terminations of units defined during the setup of individual modelers. So nesting could be a unit within another unit. It will not protrude. And then we also would have, say, things like you could have a vein terminating against another vein or terminating against a fault or something like that. So we have all these different options that we can explore, and it also will effectively filter out the data across the terminations if specified. So you can choose to use that data across that termination or not. Allows for broad naming of units or concatenation of names based on nesting relationships. So for example, if you've got something within fault block 1 and the name of that fault block is FB1, then that FB1 will be concatenated onto the name, so that you can identify that particular unit existed in fault 1, or you can have it use its parent name. It takes the geological sequence also takes advantage of spatial redundancy, so that you don't necessarily have to process over the entire geological model, and this will speed up processing. You can choose to output either as an estimate at grid locations or as solids. You don't necessarily have to extract the solids. Estimates at grid locations is also an option, and supports the individual color definition or providing a domains object when extracting the solids, so that you don't have to manually color. It should be noted that the geologic sequence can accept pre-processed or unprocessed data. And it can also accept closed manifold solids for use in constructing the final Boolean geological model. So we can just jump into a demonstration of basically how this works. For the first example, I'm going to show just a very simple example. I've made a couple of solids. So I've made just some basic blocks, and we can have a look at what I basically made there. I made these 3 cross-cutting solids, and we're going to make these interact in our geological model. So what I'm going to do is I'm going to set up GeoSeq is what I'll call this, and I'll set up an let's just go geo.GeologicSequence, and let's call our background, I don't know, we can call it, just whatever, background. Okay. Oops. Typo. Then we can add a model to that. So let's add our rock 1, and we can just copy these twice and just. So this is just a very simple geologic sequence. When what we're doing here is we're adding these rock types. This will be considered the youngest, and we'll overprint this one, which will overprint this one. Okay, so then if we can actually preview what that relationship is going to look like by just looking at the hierarchies there. So we can see we've got a boundary with no topo provided in this particular example. So it's just going to be clipped to a boundary. And that boundary is essentially going to be the extents of your grid when you provide a grid to extract the solids. Okay, so then if we extract our solids from that, we can say, okay, we can go 2 solids, and then we'll want from the spatial extents of our data, because these were actually defined based on sitting in that data space, and then we can just view those. Okay, so now what you'll see is that we have a background and then two different, whoops, I've made a mistake there. I'll just go back, find the same rock type twice. Okay, there we go. So there we have our different rock types, and then if you actually look, if we take rock type 1 away, you can see it's clipped through there, and if you take rock type, so if you take there, you can see this has been clipped by 1 and 2. Okay, so that was a very, very simple example. So let's get into something a little bit more complex. Just to actually show, if I'd added a topo to this, I just set my topo and run this, then we'll see it will clip these to the topo. Okay, let's move on. Let's go to a little bit more of a complex example. So we want to nest stuff within other stuff. Okay, so we can go quite crazy. So let's out here and let's just copy this one. Okay, and all we have to do here is just copy that. Okay, so we've added our rock one, and then what we can do is we can say parent equals rock one. Okay, so you can see, and if we want, we can define a background name here, and we call this background name rock one. And why don't we go and get more complicated here and assign this parent rock 2. So this one is nested within the other, and then we set this background name to rock 2. So there we can see now that we've got this complex relationship where we're nesting. So we have rock 1, okay, which is being split into rock 2, and whatever is remaining of rock 1 is going to be called rock 1. Same for rock 2, can be split into rock 3 and rock 2. So this is going to clip rock 3 within rock 2, and then the remainder of that is going to be called rock 2. And then we can do exactly like we did before. We can just take this line here where we can extract the solids, and now we'll see we've got that background still, but really we only have rock 1, which is cross-cutting through that, and then we see that rock 2 is being nested with it, is being clipped by rock 1, and rock 3 is clipping rock 2. So you can get really, really creative and go very, very deep with your relationships in this geological sequence. Okay, but really the example I showed you is not really our intended use of this geologic sequence. The way we would normally do it would be we would set up a vein class, okay, and then we would add some interval data to it. So you can see it's remembering what I did up above. So number 3 is that vein that we're trying to model. And if I want, I could preview it. But I'm actually not going to preview it right now. I'm just going to jump straight into Geological Sequence and just show you that you actually don't need to process this at all. So we can set up our Geological Sequence, setting our background name to background. We can set our topo again. We can then add a model. We don't have to set a background name because we've got nothing nested within it. And then we can view this geologic sequence. And there you have your topography vein and your background. And then we can, like we did before, we can just extract the solids from that. And we can view these. So there we've got a snap vein which has been clipped to our topography So now, one thing I just want to mention is that it's giving us a warning here. And what it's doing is it's telling us that the topography is not covering the total extent of our grid. And what it is doing then is it's remeshing our topography based on calculating a distance closest to topography, so that it extends over the extent of our model. So what you might notice at the edge is this doesn't look too bad actually, but what you might notice sometimes is some artifacts on the edge where the topography surface is being extrapolated. Okay, and that's the end of the geologic sequence video. We'll get into more detail with this when we start going into more advanced features.